is over ratio tables and rate tables. But before we begin, let's do a do now. Let's review our last lesson over complex fractions and unit rates in case you're still having some misconception. Sarah can walk 3.5 miles in 1.5 hours. Calculate her average speed in miles per hour. So a rate is over miles per hour. So when it says so let's write our problem into a rate problem. So she can walk 3.5 miles in 1.5 hours. But however, we want to find out how many miles can she walk per hour. Per means divide. Also, per hour. How many units is that? Is that one quantity, two? What? Oh, it's one. So they want us to figure out, let's use 1 hour miles. Don't forget the label. We're talking about rate. We need to label with units. So, I need to break this down. How can I break 1.5 hours down into 1 hour? I can by dividing by 1.5. Because if you divide 1.5 by 1.5, you get 1 hour. So what is 3.5 divided by 1.5? Oh goodness, do you still remember how to divide mixed numbers? So let's see. We have 3.5 divided by 1.5. So 3.5, how do you write this as a proper fraction? 7/2. How do you write 1.5 as a improper fraction? 3/2. So when you divide fraction, what do you remember about dividing fraction? You need to do something. Oh, you need to change this into a multiplication expression by multiplying the reciprocal of the second number. So what is the reciprocal of the second number? 2/3 multiplied by 7/2. So you get 14/6, or 2. How many groups of sixes go into 14? 2 groups. 2 groups, which is 12. 2 and 2, 6, or even 2 and 1/3. So Sarah can walk 3.5 miles in 1.5 hour. That's the same thing as saying in 2 and 1/3 miles in per hour. So every hour she walks 2 and 1/3. If she walks another hour, that's 2 hours, that'll be 4 and 2/3. And so on. So, and that's why 3.5 mile and in 1.5 hour is less than this, less than 2 hours. And 4 and 2/3. So that is how you do complex fractions and unit rate. Again, what are complex fractions? Is when you have a fraction in either the numerator or denominators. So with unit rates, you will have to break it down to a unit, to either 1 hour, or it could be 1 plum, 1 pound, 1 something. So look at my last lesson over complex fraction and unit rates if you need more questions of this. Today we're going to talk about how to how to do ratio tables or rate tables. You're going to be icing cupcakes and selling them at McMeans Junior High. In an icing recipe, the instructions say that to ice one batch of cupcakes with green colored icing, you will need 2 drops of blue and 5 drops of yellow to make one batch. How many drops of food coloring would you need for 1 batch, 2 batches, 3 batches, and 4 batches? Complete the table using your rainbow cubes or crayons. The table is called a ratio table or a rate table because the columns are filled with a pair of numbers that have the same ratio. So let's look at the ratio table we're talking in question. This is a ratio table where you can fill in the numbers in a table and they're going to have the same ratio no matter which column you use. So let's go back to it. To make one batch, you will need 2 drops of blue and 5 drops of yellow. So I'm going to use colors. So 2 drops of blue, 5 drops of yellow. Yes, I know this is not yellow. Let's just pretend it's yellow. So what's the ratio of blue to yellow? You can write it as 2 to 5, 2:5, or 2/5. If you want to be even more into more extreme, you could write it as a decimal. 2 divided by 5 is 0.4. if you want to do it that way. You don't have to. Now, what is the simplify? It's already simplified. So I just bring everything now. Same answer. So you know what? I'm just going to copy 2/5. All right, so we make another batch of cupcake. So one batch involves 2 and 5 yellow, but we make another batch, we need to add another 2 more drops and another 5 more yellow drops. So what is now the ratio of blue to yellow? It's 4 blue to 10 yellow. 4:10 or 4/10, which is the same decimal as 0 and 4/10. And what's the simplified ratio of this? 2 to 5, 2:5, 2/5. Hey, it's the same answer as our last one. That's why this is a ratio table, because it's all has the same simplified ratio. Let's make another batch, a third batch. So first batch you needed 2 drops. 2 drops, and you need another 2 drops to make 3 batches. The first batch needed 5 yellow. The second batch needed 5 yellow. The third batch needed 5 yellow. So what is our ratio of blue to yellow? It is 6 to 15, 6:15, 6:15. The decimal, if you do 6 divided by 15, we get 0 and 4/10 times blue to yellow. So if you simplify this, divide both numbers by 3, you get 2 to 5, 2:5, and 2/5. Hey, it's again same simplified ratio. Amazing. All right, for our next one, I want to make 4 batches of cupcakes. 1, 2, 2, 2. So in my first batch, I need a 5. 1, 2, 3, 4, 5. I need another 5 to make another batch. I need another 5 to make another batch. And I need another 5 to make another batch. So, what's the ratio of blue to yellow? I see I need 8 blue to 20 yellow. 8:20, 8:20, which is the same thing as the decimal. If 8 divided by 20 is 4/10 or is 40 hundredths. Can you simplify that? Yes, you can. Divide both numbers by 4. It'd be 2 to 5, 2:5, 2/5. And it's again the same ratio. So as you notice, in a ratio table, we have the same ratio. Because what you're doing is you're just increasing. You're doubling it. You're tripling it. You're quadrupling it. We are going to learn a shortcut very, very soon on the next one where you can just multiply both numbers by 2, create the same ratio, how building it up or breaking it down, or scaling it up or scaling it down. Or you can say scale it forward, scale it backward. So many ways to say this. The number by which you multiply 2 related quantities by the same number is called scale factor. So, for example, we have 2 blue, 5 yellow. If I made it into 4 blue and 10 yellow, I am doubling it. So I'm multiplying by 2. So the scale factor is 2. So because I'm multiplying by 2. If I wanted to make 3 batches, I had to multiply by 3 or triple it, which is a scale factor of 3. So sometimes you need to scale back or scale forward. You build it up, break it down, all means the same thing. So Ray's heart beats 56 times per minute. At that rate, how many times will her heart beat in 7 minutes? So we've already set up the ratio table. I am so nice. I labeled it for you with the units. I even put the numbers in the correct spot. Don't worry, in the next few slides, it's not happening. I'm not that nice. So in this one, because you have to think. All right, so are we going to build it up or break it down? Scale it forward or scale it back? I think we need to build it up. So I think I need to multiply by 7. Multiply by 7. For 1 minute to 7 minutes, I need to multiply by 7. That's the scale factor, by the way. So what is 56 times 7? That's 42. Carry the 4. 37 times 5 is 35 plus 4 is 392. So 1 minute, you have 56 heartbeat. It's the same as saying 7 minutes, 392 heartbeat. If you simplify this, they will become 56 heartbeats in 1 minute. That's why it's a ratio table, because the simplified ratio of this is the same as this. So we build it up by multiplying by 7. finding the scale factor of 7. All right, next one. Patrick can make 8 chairs in 20 hours. At this rate, how long will it take him to make 2 chairs? So again, I labeled the units for you in this rate, chairs and hours. 8 chairs takes 20 hours, 2 chairs. Are we going to scale forward or scale backward, or build up or break down? I think we're going to break it down. How do you break 8 chairs to 2 chairs? By dividing by 4. Dividing by 4. So 20 divided by 4 is 5. So he can make 2 chairs in 5 hours. So what we did was break it down. If you want to be, I don't know if you want to get to this level, but if you wanted to find a scale factor, what would you multiply 8 by to get 2? This is actually, I think this is an upper grade level question, but this is only for those who want to know it. Some of you might say, fast forward. You're multiplying by a scale factor of 1/4. Because 1/4 of 8 is 2. So 1/4 of 20 is 5. So, again, how do you know that? Right, 8 over 1. 8 times 1 is 8. 1 times 4 is 4. How many groups of 4 go in 8? 2. So, but most of us for 6th grade, we just need to focus. You're breaking it down by dividing by 4, which is the same thing as saying multiply by 1/4. Remember, the reciprocal of 4 is 1/4. So again, if this was confusing, fast forward. All right, number 3. Skim milk contains 80 calories for every 8 ounces. How many calories do 10 ounces of skim milk contain? So, So you have 8 ounces of milk. I did not label this. All right, this is about calories. So the whole question is about ounces and calories. 8 ounces has 80 calories. 10 ounces will have, oh goodness. Let's say I need to build it up. Oh goodness. Not a compatible number. What do I want to build it up times what? I mean, I could not times it by 1 point something something, but you know what? Why can't I just break this down and build it back up? So if I broke this down, 8/20, by dividing both numbers by, what do I want to break this down by? Dividing both numbers by 8, that would be 1 and 10. 1 ounce has 10 calories. Then I can build it up by multiplying by 10. So 10 ounces have 100 calories. So, so you can sometimes break it down, then build it back up. Or scale it down and scale it up. Number 4. Joseph mows lawns during his summer vacation to earn money. He took 14 hours last week to mow 8 lawns. At this rate, how many lawns could he mow in 63 hours? So number of lawns. So what is the rate? This is about hours and lawns. It takes him 14 hours to do 8 lawns. At this rate, how many lawns could he mow in 63 hours? So I need to build it up or scale it up. Scale forward. So what do I multiply 14? What compatible number? What can I multiply 14 by to get 63? 14, 28, 42. I don't think it even goes into it. Oh, could I break this down to use easier numbers work? If I were to break this down, what would you divide both numbers by? By 2. So it'd be 7, 4. So 7 hours, you can do 4 lawns. Then I can scale it up or build it up by multiplying both numbers by 9, get 36. Yes. So 63 hours, you can do 36 lawns. Pablo bought a $50 gift card for $45. Use a ratio table to find out how much he would pay for a $30 gift card. Oh, Mr. Joe did not even label these for us. How rude. All right, so what is this about? This is about gift cards and how much he paid. So that's what the units are. So it's a ratio. He paid $50 and he paid $45 for that. Use a ratio table to find how he would pay for a $30 gift card. $30 gift card will go up here. So we'll have to scale it down. If I want to scale this down to 30, what do you divide by? I don't even think it's compatible. I don't even think you can do that. Why don't we scale it down to easier numbers and then build it back up, scale it up? So if I want to break it down, what would you want to break both of these down? Divide both numbers by 5, I guess. And that'll be 10 and 9. So if you buy a $10 gift card, you only have to pay $9. But then we can build it up or scale it up by multiplying by 3. And $27. So a $30 gift card, you will spend $27. So for every $10 gift card, you pay $9. So for $20 gift card, you pay $18. $30 gift card, you pay $27. So that's the answer for that one. And the last question. Xander read 30 pages of his book in 10 minutes. That's a lot of pages. If he continues at this rate, how long will it take him to read 45 pages? So what is this about? The rates, let's see, the units are about pages and minutes. So let's label it pages and minutes. He can read 30 pages in 10 minutes. How long will it take him to read 45 pages? Label it right here. Make sure you put the 45 in the correct box. If you have put it below it, you're saying it's taking 45 minutes. He's not that slow of a reader. Or, yeah. So, let's see here. Let's scale it up. Build it up. What do you multiply 30 to get 45? By 1, by 2, by 3. Doesn't go in perfectly. You know what? Let's scale it down and build it back up. So, is there another way to say 30 pages in 10 minutes? What about if I divide both of these numbers by 10? And so that would be 3 and 1. So every minute he reads 3 pages, or 3 minutes per minute. Now let's scale it up or build it up. Times 15 times 50. So 15 minutes he can read 45 pages. So this is the study of building ratio and rate. Oh, that's kind of cool. Building ratio or rate tables. So sometimes you're going to have to build up, then break it down until you can come right to your final answer. And so you'll be able to complete this table and find the ratio. And then if you simplify every one of these columns, they will all have the same ratio because you're building up ratios or breaking it down.